Here's another interesting application problem on exponential functions. Right, this is from my collection of last 10 years of question papers that I'm sharing with you. These are very good problems, and if you do them, then you should be expecting very good marks in your test. Now, question number 26 says, a biologist tracks the population of a species of insects in a contained area over several years. Now, with years, they're given population here. So 1, 2, 0, 1, 2, 5, the population was 160, 200, 250, and this is 3 and 12. So we can't have it in decimal numbers, 390 and 488. So that's a typing error. So we need to determine the equation that models the insect's population growth. That's first thing. And second is determine the population after 10 years. So once we get a model here, we can plug in t is 10 and then find our answer, correct? Now, how to find exponential equation for this? Now, why exponential? Now, let us see the first difference. The first difference is here. If you see 60 and 20 is around 40, correct? And then it becomes 50, correct? So the first difference is not same. So first difference is 40 here, and then when you do this, it's 50 here, correct? And 312 means 50 plus 12, which is 62. And then likewise, you see it is increasing. So it is definitely not arithmetic series, right? So it is increasing and it's not arithmetic series. So what could it be? So the second option is a geometric series. To find whether it is geometric series or not, what we can do? We should divide this by this and see, is it by going up by some factor? So let's do 200 divided by 160 divided by 1. We do 200 divided by 160 equals to, we get 1.25. So if I do 200 divided by 160, so I get 1.25. Now let's do 250 divided by 200. 250 divided by 200, we get 1.25. Similarly, let's do 312 divided by 250, and we get 1.248. Let's do 390 divided by 312, and this gives us 1.25. And 488 divided by 390 gives us 1.251. So we see that the ratio of consecutive terms, right, is 1.25, correct? So here we got this by dividing 488 over 390, right? And if we did 390 divided by 312, we got this number. And similarly, we found all the ratios. They are very close, and in fact they are close to 125. Therefore, it seems that every year the population is getting multiplied by a factor of 1.25, right? Since it is that, we can say it is exponentially growing and the base is 1.25, right? So that helps us to write down the equation of this function. So it says determine the equation that models the insect's population growth. So we say population Pt is equals to initial population, which is at t equals to 0, is 160, right? Times 1.25 is the growth factor to the power of t, correct? So if we write t equals to 0, we get 160, which is this. And if I write t equals to 1, after 1 year, that is, then it is 160 into 1.25. If I multiply 160 by 1.25, I get 200, correct? Next year, I have to multiply again by this growth factor of 1.25. When I multiply 200 by 1.25, I'll get 250, correct? And when I do the same, I'll get a value which is very, very close to the population, right? So therefore, this model represents the data given to us, right? And that's the way to find a model for a given situation, okay? And now the question over here is, determine the population after 10 years. So after 10 years, it will be P of 10. So we can write this as 161.25 to the power of 10, right? So here we can calculate 161.25 to the power of 10, which is equals to 1490, right? So which is equals to 1490. So the population will be 1490 after 10 years. So I hope you understand how to convert from data to an equation and find the value, right? So like this, with a formula, we can extrapolate the information. Thank you.